So now we are going to dwell into the world of pointers that point to a data type. So let's talk about, what it means to point to data of a specified data type. So consider, for example, the example that we have been using, like a character pointer, maybe P, that points to, let's say, a character, and then we had, C as, for example, A. What this meant was, again, going back to our beautiful representation of the memory as array of bytes. So we mentioned that somewhere there was a byte which was allocated to C, and we had A there. And then somewhere else in the memory, there was P, which was some number. And that some number was essentially, the uh, address of wherever C was essentially assigned, like at the memory location, and wherever the A was stored corresponding to C. The question is, when we do a star P as a dereference operation, right? So the dereference operation essentially, the compiler or the CPU understands, the compiler understands in terms of what code it needs to generate. It understands that it needs to go to this location and then get 1 byte from it, right? And what do I mean by get 1 byte from it? It means that, the information about how many bytes to read, and that is the absolute key about pointers that point to data type related data, that the information about how many bytes to go read is because contained or available essentially because the data type has been specified, right? And because of this data type being specified, it is known that P is pointing to memory location from which 1 byte must be read if the dereference operation happens, right? So similarly, let's take another example. So let's say if we had int, I don't know, I equals to 10, and let's say on our machine an int, size of int is let's say 4 bytes, 4 bytes. So then something like this would essentially mean that somewhere there is pi, which is again having mm, some some address like this, and let's say I is here, whose address is right, whose address is something like so, and we have 10 stored here. Now note that the starting address would be this, meaning this address is this number, but the I itself spans 4 bytes, right? And so when pi is the pointer pointing to the I, meaning actually it's pointing to like the first byte of I, when we do something like so, it is understood that we are supposed to go to this memory location and then read 4 bytes from there. Not one, not two, but 4 bytes. And that is contained, that information is available because we are specifying the data to which the pointer is pointing, right? And so with this as the background, like with the data type, you must bring to this. If the data type of the pointer is available, then the pointer dereference will kind of, so to speak, hug as many bytes in the memory as the data type dictates, right? And now let's essentially go to an example and see, if we can understand. Okay, let me. Interesting. Uh, okay, so yes, so let's then go ahead and try and understand through example what's happening here. So I have four types of variables here: A, which is a character; B, which is an int; C, which is a float; and D, which is a long int. Now, in terms of space occupied, this would be 1 byte, this would be 4 byte, this would be 4 byte, and this would be 8 byte, right? That is how it is. And then what you see here is essentially pointers pointing to A, B, C, and D, and that is represented here using the ampersand A, ampersand B, ampersand C, and D. And what I'm doing here is printing the size of dereference PA, dereference PB, so on and so forth, as here, right? The point being that we will get to know how many bytes this pointer has dereferenced, or how many points it will dereference. That is one. And the second one here is my attempt to again dereference the pointers, but also modify the value in them, right? And then we go ahead and again dereference the pointers here and print those updated values. And again, I have kind of already run this example here. So gcc main.c a.out. You'll notice that we see 1448, which is matching with 1448. And here we have the modified values, which is A got upgraded to B, 1024 got converted to 1025, and 1.0 got converted to 2.0, and 12345 got converted to 12346. So this hopefully convinces you as to the notion of pointers pointing to data with an associated data type. The important thing is that the data type conveys how many bytes the pointer needs to read. And this becomes more interesting when we talk about structures and typecasting pointers, and that we'll take a look at in later videos.